Hello all, welcome to my routing and switching video series. This is part number 3. In the last series we have seen we configured the BGP. In the first series, for video 1, you have seen we configured the OSPF. In part number 2, you have seen we configured the BGP. Now the router 1 has BGP pairing with router 2 and router 3, but still we don't see a few routes available in router 1 routing table. Here, if I go router 1. Show IP route. As you see, even though the BGP is up between my data center 1 and data center 2, 110 dot and 172, we are still not learning any directly connected networks behind the router 2 and router 3, like for example 30 dot network and 20 dot network. And we are also not learning 188, 178 or 143, 153 and 133 network also in the routing table, even though our BGP is up. So let's address that issue first. My target is to bring so basically in this video we will be advertising our first step. Number 1 is directly connected routes on router 2 and router 3 to the router 1. Then step number 2 will be advertising any networks, any subnets, any network behind external switch 2 and switch 3 from router 2 and router 3 respectively to the router 1, right? So as you see, router 1 doesn't have any of those routes in its routing table. So I will go on to the router 2. We'll do show run sec BGP. I will give a small command here. After that command, we will see all the directly connected networks on behind the router 2 and router 3 will start advertising to router 1. For example, this 20.1 network, which router 1 doesn't have in its routing table, as you see here. So we'll router BGP 200 redistribute connect. Let's see the magic of the command. Show IP route. Now you see that 20.1.1.1.0 network is in my routing table. So we kind of only have the problem. We still don't have VLAN 40 network or 178, 188, and 168 network in our routing table still. So that will be step number 2. But we resolve this issue of directly connected routes on router 2 are now being advertised to router 1, and I can. So let's do the same thing on the router 3. The router 1 still doesn't have this 30 dot network in its routing table, as you see here. We only have 20, which we just resolved. So let's go to the router 3 and show run sec BGP. On F2, we'll give the same command here. Redistribute connect. And Alright, now you see that we have 30 dot network, which is sitting right behind the router 2. Router 3 is also being advertised to router 1. Alright, so far anything connected directly between router 1, router 2, router 3 has been shared among these routers. Now we will go ahead and configure the routing issue. I will say where VLAN 60, VLAN 40 from data center 1 and data center 2, and this network's web database and app networks 188, 178, 168, 153, 143, and 133 are still not there in the routing table 1. As you see here, router 1 still doesn't know those routes. So we're going to troubleshoot this. So same thing again here. Show IP BGP. So the problem why we don't have those routes, because if you recall from the video series 1 and 2, we have OSPF behind this router 1, router 2, and router 3, right? So router 1, router 2, and router 3, they know their local networks. They have learned from OSPF, but we need to have a mechanism where we put this OSPF route into the BGP and ship it to the router 1, router 3, router 2, and router 3. And same thing, we have OSPF behind router 2. We need to put those OSPF routes, it's learning from external switch 2 and router 2, put them into BGP and push it to the router 1, right? So let's do this first on the router 1. If you see, if I go to the router 2, show IP route, router 2 still doesn't have any network behind the router 1, like 100 dot network, 200 dot network in its routing table. As you see here, we don't have that. So let's resolve the problem. So I will go connft router BGP 100. Before I do that, let me also do this show run sec OSPF. Alright, so we'll go connft. I'll get into my BGP configuration or the BGP, right? Now we'll give this command redistribute OSPF 100. I will just call the OSPF 100 my OSPF process ID 100 into BGP, and now I'll see what happens. As soon as I give the command, all those routes I'm running from OSPF should be advertised to my BGP peers now. Should I be wrong? Indeed, I see that now. 200.1.1 is in routing table for router 2, and I should also see 100 dot network. As you see here, just before that command, we did not have those routes in my routing table. There you go. And same thing with the router 3. Show IP route. So as you see here, the route 100 and 200 networks are in my routing table. Now, so we can have resolved this problem 50%, I will say. The router 1 still doesn't have those routes. We still don't have any route behind the router 2 and router 3 in my routing table, like VLAN 40 route 40.1.1 or these routes. So we will do the same thing here in router 3 and router 2. So let's do that in router 2 first. Show run set BGP. I will just make sure what is my BGP configuration and OSPF configuration also. Connect router BGP 200 redistribute, sorry, OSPF 100. That's my OSPF process ID. And so if I jump onto my router 1, so far I did not have that 40 dot network in my routing table, and we did not have this 168, 178, 188 network in my routing table. So that command after I gave on the router 2 should resolve that issue. There you go. And I have 188 in my routing table, 168 as well as 178 in my routing table, right? And we also have VLAN 40 network 40.1.1 in my routing table, right? So we'll set this configuration for now. So now if you see here in this routing table on router 1, let me move all these console windows. We still don't have 133, 143 and 153 network in my routing table on router 1, right? And we also don't have the 60 dot network in routing table. If you see, we don't have that. So let's do the same command on the router 3. Show run set BGP, just to see what is my BGP configuration, as well as my OSPF configuration. I'll go connft. I'll go into my BGP 300 redistribute OSPF 100. This is the process ID in my OSPF 100 and on the router 3. You could have a different process ID, it doesn't matter, but sake of this video I just configured all of them in process ID 100, but we have a different area numbers here. Right. So let's hop back to the router 1, show IP route. Now I should have those routes in my routing table. 133, 143 and 153 routes in my routing table, which is coming from a Dallas data center, right? But one thing very important to notice here, even though I have those routes, I might not be able to ping those routes, even though I'm running them, but I still won't have connectivity reaching these networks. If I go to ping, see that I cannot ping them those networks, right? And the other way around, if I go into the router 3, I do show IP route here. I'm running the 100 dot and 200 dot campus networks in my routing table, but I might not be able to ping them. I'm not in a position to access those, ping them or say hi to those guys sitting in the campus, right? Through text. There you go. The reason why we are not able to ping across each other, even though we have the routes in routing table. For example, the router 1 is learning 133, 143, 153 routes from router 3 in its routing table, right? But external switch still doesn't have those routes. You see here, show IP route. External switch, this guy is still blind-sided. It's kind of a blind. It doesn't have anything in its routing table. So router 1 knows everything. It's kind of Oracle now. It knows everything, all the routes in its network. Show IP route. If you see here, the router 1 has tons of routes in its routing table now. You see that? But it's not giving those routes to external switch 1. So now we'll put some configuration here on router 1. After that, router mode will be advertising whatever it has learned from the different router 2 and 3. It will start sharing to the external switch 1. Right. So like we did earlier, we took these routes from OSPF 85, put them into our BGP 100, and we started throwing them, pushing them towards router 2 and router 3. We did the same thing here in our data centers also. We took whatever routes we have behind this external switch 2 and 3, we put them into BGP, we started shipping them to router 1. Now what we're going to do is we will take the BGP routes on router 1, whatever it has learned from its BGP pair 2 and 3, we put them into OSPF and we'll start pushing those routes to the external switch 1, right? Or you guys are still confused? So earlier what we did, we took this OSPF route, we put them into BGP and we started advertising to our BGP peers. Now what we're going to do, whatever the routes this router 1 has learned or 2 or 3 has learned on the BGP, we'll put those BGP routes into OSPF and we start giving them to our network sitting behind them, basically our core switches, right? So I will go here, connect router OSPF 100, my OSPF configuration, redistribute BGP 100 subnets, right? So once I give this command, what it does, my BGP, my AS number 100, the BGP configuration on router 1, it will start what all subnets I have learned on from the BGP peers. I will start advertising to my OSPF neighbor. Who is the OSPF number? External switch 1, as you see in the diagram here. Now let's go and from here I will go on to the external switch 1. Now before I give this command, this was my routing table. Now I would see something, I would start seeing more routes in my routing table here. Show IP route. There you go. That's the magic. See, now external switch 1 has all the routes in my routing table, whatever the router 1 has. If you see here, we have 30.1 dot network route. Where is the 30? If I move this console, 30 is the network, point-to-point network from router 3 to this external switch 3. We have 133 network all the way sitting in the end of my data center. The app network, application network, that's subnet served for the application VMs. And what is the database? 143 DB. We have 143 network in our routing table. 153, 153 here in my routing table. We also have the New York routes, 188 in my routing table. There you go. 178, 168. Right. You see that external switch has all those routes now, right? Okay, so this is the result here. Let's go on to the external switch 2 and see if the external switch 2 and 3 are learning the campus routes. So they won't be doing that because we still need to do this exactly the same configuration we did on external switch 1. If I do show IP route, show IP route. So external switch 2 have only limited routes. As you see here, 168, 20, 188, 178, and 40 routes. It has no idea about this 100 and 200 dot networks. So let's go ahead and resolve that. So I would go into the router 2, show run sec BGP and OSPF, just to make sure my configuration. I will go into OSPF this time. Router OSPF 100, redistribute BGP 200 subnets, and see the magic. We only had these routes, right? We did not have 100 dot 200 dot routes in our network. Now you'll see what happens. Oh, sorry, not here. There you go. We have 200 as well as 100 route in my routing table. And I believe I should be in a position to ping, say hi to the people sitting in the campus network. So ping 100.1.1.1, the default gateway. And this gentleman sitting here has .2 IP address. Let's see if I can ping him. Yep, there you go. Let me go to this desktop and see if I have connectivity to 1.88 network, which is sitting in our data center 1 New York location. So the campus 1, I'm logged into campus 1 PC. Ping 188.1.1.1. There you go. I'm able to ping the web network. I'm able to access whatever the VMs on the web network. I should also be in a position to ping 178 in my database. Oh, sorry. Database network 178. See, I have full connectivity on 178 and 168 also. Just to prove that we have full point-to-point connectivity. And how about the person, gentleman sitting in the campus 2? He should be also able to achieve this. So the user sitting in campus 2 also have full endpoint connectivity all the way to my database, application, and web network in my data center. But the question is, am I all the user in campus 1 and 2 are able to ping this network in Dallas? I don't think so. Let's give it a try. And the reason why, because external switch 1 might not have that route in its routing table, because we did not put these OSPF routes into router 3, so that router 3 start shipping those routes to the router 1. And to prove that, if I go here on the external switch 2, show IP route, I don't have any 1.33 network. I'm sorry, I do have one. I think we already configured, we already did that in router 3. Let me confirm that. Let's go to external switch 1, 133, I have it. Ping. Oh, sorry, my bad. Yes, obviously, we are learning this route on external switch 1, right, for 133, but this guy might not have those route. So for example, say like the packets leaving this campus 2 know how to go to the router 1, to the external switch 1, to the router 2, router 1, then router 1 to router 3 to this, but the return traffic doesn't have the route to the 100 and 200 dot networks. Let's go to our campus switch, external switch 3, show IP route. Right, so our routing table is still very limited because I did not redistribute the BGP into OSPF here, right? And to prove that, show run seg BGP, not NGP. Something new, I guess. Oh, I'm sorry, my bad. I don't have BGP on external switch. I only have OSPF. So I mean, let's log into the router 3. Show run seg BGP. All right, redistribute OSPF 100 connected. Show run seg OSPF. I did not give the redistribution command BGP into OSPF 100, so that's why we don't have that. So let's go here, connft OSPF 100. Let's redistribute the BGP here. Redistribute BGP 300 subnets, and right now external switch 3 should have routes from campus 1, campus 2 location. If it doesn't, then it's not a good thing. Alright, it does have 200 and 100 routing table. So this user in campus 2 should be in a position to reach the Dallas network. There you go. So this PC2, this user 2 sitting in this campus 2 location is able to ping 133.1.1 network in Dallas data center here all the way. How about the other network, 143? Yes, he can. How about the user 1 in campus 1? He should also be able to. There you go. So now we have full connectivity. So one more last thing. Let me log into the external switch 3. And let's see from this side, we have connectivity to campus networks. Ping 100.1.1.2. There you go. Dot 2 is this user and 100 network on a campus 1. From external switch 3 in data center, I am in a position to ping this user here all the way. So with this, we did prove that now we have full end-to-end connectivity from campus 1 and campus 2 to all the way till DB, app, and web services and networks in our data center 1 and data center 2. I will go and save this configuration on all devices. Right, ma'am. So that I don't have to do this configuration again and again. Right, ma'am. Right memory. All right, so with this I will put an end to this video. Video series number 3. In the next video, we would be looking into load balancing stuff. What I'm saying, what I mean by that is now that router 1 has route for this web interface, right, 100.100 and 133. So what I'm going to do in the next video, we will have one common network on this board network, right? And say like we'll configure a loopback interface with the same network. Say data center 1 is a primary, data center 2 Dallas is secondary, and we'll make one DC a primary, other, I mean, as of now one should be primary, second should be secondary. So what we're going to do in the next video is we'll put a one common network, right, on this, for example, say like we'll create some network on both locations, and we'll see if I try to reach that particular network from campus 1 and campus 2, which route it's taking preferably, right, ISP 1 and 2. So we're going to do many such scenarios now that we have full point-to-point connectivity. We'll play around with BGP load balancing. There are various ways we can do that through AS path preference, through local preference and all. We will be creating route maps, IP prefix list. There's a lot of stuff coming later in this video series, and it's getting very interesting. We just started scratching the surface on BGP configuration. We'd also be doing videos on OSPF, EIGRP, troubleshooting scenarios. I mean, I have run into so many routing and switching issues, very complex networks, and very confusing kind of stuff. But whatever I can recall, I'm going to share in this video series. All right, thank you so much. I hope you enjoyed this video. Thanks for your valuable time. I hope you enjoyed this too. So catch you in the next video. Thanks.